Hi guys, how are you? Last lesson for the week. We are taking a little break from circles and we're going to do a little bit of algebra. So this is systems of equations. I would guess that most of you have already done systems of equations, at least to some extent. And so it's just going to be a review of that. But yeah, hope you guys are hanging in there. Last thing for the week. Next week we'll do 2 little things and then spring break. Woo! Very excited for spring break. Be nice to get away from the screen for a little bit. Okay. Here we go. Systems of equations. So we're going to focus on solving systems of 2 equations with 2 variables. And chances are this is a review for many of you. You do not have to do this part up here. If you want to, you can just skip ahead and do these 12 problems here that you're responsible for. I will do some of them. Okay, let's see. 3 ways that we're focusing on solving them. We've got graphing, we've got substitution, and we've got elimination. So I will never insist you do a certain method. You can do whichever way you want. I'm just going to encourage you to pick the smartest way. I think seldom is graphing the smartest way. But if you were to graph 2 lines, 3 things could happen. The 2 lines could intersect. The 2 lines could be parallel, and the 2 lines could be actually the same line. If they intersect, you have 1 solution. If they are parallel, you have no solution. And if they intersect, if they're the same line, I don't like to say infinite solutions. I like to say it's all points on the line. I do not like to say it's all real numbers. It's not really all real numbers. It's all the points that are on this line. They're the same line. So this point right here is not a solution. So it's not all of the solutions. There are an infinite number of points on the line. And the solution is all the points on the line. Substitution method, I would do whenever one variable is isolated. Whenever one variable is already isolated, I would do substitution. I would do elimination, otherwise known as linear combination. I would do it whenever one of the variables isn't isolated. I would multiply by a factor and get either the x's to cancel out or the y's to cancel out. It is totally up to you which method you use. I would just encourage you to use the smarter method. I will never tell you solve this one by this method. Another quick thing is just to reiterate, when they intersect, there's 1 solution. When they're parallel, there's no solution. When it's the same line, it's all the points on the line. I would just discourage you from saying all real numbers, because it's not all real numbers. It's not this number. Okay, let's try a couple. I'm going to try number 2, 3, and 4, and the rest are up to you. Okay, here we go. All right, number 2. I've got this system right here, and I notice that one of the variables is already isolated. X is already isolated. So I'm going to take this and plug it in for x. I can do it any way I want to, but I think the easiest way on this one is to take all of this and plug it in for x. And when I do that, I'm going to get 1 equation with 1 variable. So here's my 1 equation with 1 variable. I can solve 1 equation with 1 variable all day long. Let's see. Why I get -1. After I do that, I can plug it into either equation, the top one or the bottom one. I'm going to plug it in the top one. And I'll get x is 4. It often says write your answer as an ordered pair. It does say that here, so I'm going to write that as an ordered pair. This is 2 equations. They intersect, and they intersect at the point 4, -1. Okay, looking good. Number 2. I can solve it any way I like. I'm going to use the elimination method here. I would not use substitution because neither x nor y is by itself. So it would just take me more steps to make it by itself. I'm going to multiply top and bottom by something. I'm going to choose to multiply the top by 4 and the bottom by 5. And when I do that, the y's will cancel out. If I'd rather, I could multiply, let's see, the top by 25 and the bottom by 8, and I would get the x's to cancel out. It's totally up to you. I like to try and keep it at a little bit smaller numbers. Okay, I just rewrote those two equations. Those two equations are the same thing as the two above. And now I'm going to add them together. And when I do, the y's are going to cancel out. Let's see. I get negative 93x. And I'll get x equals 114 divided by negative 93. I'm going to make my calculator go ahead and simplify for me. Negative 38/31. That is just a wonderful answer, isn't it? I'm going to plug that back into either equation. The top one looks a little bit easier, so I'm going to plug it into the top one, a little bit smaller. Make my calculator do the work. Times 8. And I get negative 160 over 31. My final answer written as an ordered pair. There we go. The other option you can always do, you can use your calculator. If you have one of the TI-84s or TI-83s, you can use the Polysmelt app. Many people are doing that. Okay, let's try number 4. Some funky stuff starts to happen, in particular on number 4. Let's see, I'm looking at number 4. Neither variable is isolated, neither variable is by itself, so I'm going to use linear combination. Well, let's see, what if I multiply the top by 5 and the bottom by 2? So I just rewrote those two equations. I'm going to combine them. When I do, let's see, negative 30 plus 30, and negative 10 plus 10, and 20 plus negative 20, I get 0 equals 0. When is 0 equal to 0? No matter what I plug in for this, it's gonna be true because these two are the same line. These are the same line, so the solution is all points on the line. These are the same line, they're just written in a little bit differently. The solution is all the points on the line. That's where these two lines intersect. These two lines intersect everywhere on that line. So be on the lookout for this whenever you get, no matter what you plug in, 0 is gonna equal 0. The other thing that's a little funky that's gonna turn up sometimes, you'll either get 0 equals 0 or you'll get things like, whoa, 5 equals 10. And you ask yourself, what could I possibly plug in for 5 to equal 10? Nothing, because if you get something like that, it's going to be no solution. It'll be evidence to say that the two lines are parallel. Okay, I did those 3. Again, I think this is a review. See what you can do with these ones. Submit it and then double check with my answers. Take care, guys.